Michael, I'll wait till you get everything ready if you want.
Yeah, where do you want to start?
Satellite. Turn the light off. Is that the lighting good with the light off, Pete? Or is that too dark?
Either way.
IR or visible?
Visible. Yeah, let's take advantage of the early sunrise.
Too early. Loading.
Yeah, that'll work great. Okay, thanks. All right, so welcome to our final weather watch of the year, and until and unless, of course, it snows.
Academic.
It's academic year. That Michael will want to convene a meeting if it snows sometime in June, July, or August.
After provisioning has been done.
Yes, that's right. After the St. Bernard's been watered and fed, you're going to come in and want to talk about it. What an interesting week we've had. I wish I had the time to have compiled all the stats. I know on one of the days, it must have been Monday, Tuesday, we had 1.3 inches of rain. I can't believe we had less than that last night with that torrential downpour that lasted a couple of hours, beginning what was around 6:30 or something like that. And it rained like crazy. Really nice relationship between that heavy rain and the cyclone that you can see depicted here in the satellite movie, moving across the upper part of the lower peninsula of Michigan. Here's a cloud mass associated with it out to the east, and it was in this warm frontal region where we were embedded last night in our heavy rain event. And you could see it coming on the satellite. It did look more like an open wave then, in terms of the way the reflectivity had just the slightest little S in it, maybe around Des Moines. And then I think now, if we were able to see the reflectivity in Canada, it would be a lot more cyclonically wrapped up than it was last night. So this storm has been developing over the last 36 or so hours. The last 24 in particular have affected us. And so now we woke up this morning with clouds and even a little shower. I think there were a couple of showers. There's one here embedded there, I think, that gave us a little bit of a sprinkle. And then that's gone by, and now there's nothing but clear skies for the rest of this afternoon, it sure looks like. Cold advection we'll see on a couple of different maps, much lower dew points. So even though there'll be daytime heating and it's easy to reduce the stability, I think the lack of moisture will probably play a role in giving us, if anything, some fair weather cumulus. You can even see some of them developing here over the Arrowhead and over the northwest part of our state in exactly the same types of conditions. So they are closer to the lake and maybe had heavier rain. So there may be just evaporation off the ground that's adding to the dew points there. But nonetheless, I suspect we were probably approaching about a 4-inch rainfall for this week, Monday through Friday, that ended just this morning. And then notice this is another interesting thing about this storm. There's an open spot here that responds to the daytime heating, because these cells not only develop in this open spot, but then they congeal and become a little bit more intense. Look at that across Indiana and parts of northwest Ohio. So we'll see that on the radar. That's a really nice development of striated lines of convection that are in an odd spot, presumably behind the cold front or just behind it. But nonetheless, they look pretty intensely convective. And we'll try and say something about the whole structure of this event over the last 24 or so hours. We're looking at that. There's more weather upstream, over Texas, parts of Oklahoma, and Arkansas. Some of these convective cells are pretty intense with 55 or so dBz level. I don't know. I think there's only a moderate risk of severe down there, and probably even slight by now. We'll try and see how that's connected to upper level disturbances further to the west. Beautiful picture at this high resolution. It's just so gorgeous. Seeing all the snow and the high peaks of the Rockies in Colorado and Wyoming, even in Montana. So really, really nice picture. You can see so much detail on these. They're gorgeous. And it looks like agriculture has begun along the coastal Carolinas, southern Georgia, and Florida. It's just a little bit of a difference in the reflectivity of the visible there, and it's probably a function of something to do with agriculture. And then we'll take a look off the west coast to see what's happening in the Pacific Northwest. There's a very intense upper trough and deep storm over the Aleutians right now. And then there's one just off the California coast, well, not just off, 1,000 kilometers or so. And then connected perhaps with a stream of flow from the subtropics that we'll see on the satellite from the west coast. Okay, before we go there though, can we take a look at the radar that covers the continental 48?
Yes, we can, John, but wait a second.
Okay.
You use the word.
Whoa. What's this?
Yes! Okay. That's all you had to say.
What is that?
That is
Arlene or something?
No, this is actually a developing, it's just an inverted trough in the west, in the easterly, subtropical easterly, south of the subtropical high. Hurricane Center is now, they've just issued a special statement on it, they're looking at this 0% chance of development through 5 days, but it's expected to bring gusty winds and rainfall into the Florida Peninsula. The numerical forecasts look at that a little bit, are suggesting that this open inverted trough is going to actually close off. And there's some indication of a warm core developing in it. I mean, it has winds north of it of about 25 to 35 knots. So it's not quite a depression. It doesn't have the structure of a tropical cyclone at this point, but it is a mid-level to upper-level vortex, which has a nice closed PV structure being advected westward across the Bahamas. So something to watch.
So inverted trough just means it's like an easterly wave, right?
Like an easterly wave, but not specifically one. It's just it has I guess mid-latitude origins.
Oh, okay.
So it's cut off and.
Oh wow, that's interesting.
So maybe one of like some tropical cyclones in you and Andy Hullum.
Yeah, and then it got caught in the big subtropical high. And then
yeah, I haven't looked at the full history of it, but yeah, it's a nice closed
yeah.
PV anomaly. But I'm thinking that there might be, what's the difference between 0 and 10%? I think there's more than a 0% chance that this could develop into something.
Yeah, this looks more ominous than saying 5 days out there'll be no further development. I would have thought that. And I did mention this in class today. I just forgot to look at it.
I was about to say, that's the most conspicuous feature.
I think you presented too small an area, and it was just barely visible. No, I don't know what it was, but I didn't see it. I look at that hemispheric one, in the infrared. That's maybe the difference. So anyway, yeah, I'm glad you pointed that out to me. So here's a radar. So our event has still got some convective cells in it that are interestingly oriented. Early on in the day, they were kind of parallel to the long axis of the lake. I'm not saying there's a lake effect there at all. I'm not saying that. But that's just kind of the orientation of them, aligned undoubtedly with elements of the synoptic scale. But this is the line of thunderstorms that kind of developed within what started the day as a somewhat clear spot, and then it kind of filled in with these lines. There's really 5 of them you can see on the visible, and 3 of them erupt in reasonably strong convection. Very linear, very interesting set of features. I'm not sure I've seen something like that in quite some time. I don't know. We'll see when we go to the surface map. Let's remember the last time we see them, they go across like that from the Terre Haute all the way up to about Akron. And let's see if that's where the cold front is. I have a suspicion the cold front is probably either a little bit west of there or a little bit to the east. I can't remember exactly what my suspicion was based on looking at other things earlier on. I think it was that it was further to the east, because this line here seems to be connected in some way to the big cold frontal portion of the circulation that's lost in Canada on the radar. And then here's the reflectivity in Texas, bearing down on San Antonio, places like that. So some really intense convective cells here. I don't know if there's anything of a supercell or rotating type in there or not, but maybe we can take a look at SPC at some point during the discussion to see what they think is in the offing here. I think overall, last week we said I think that there have been no tornadoes in Oklahoma through whatever the day was on Friday.
Right.
And they didn't get any in April, but on May 1st they finally did record a tornado. I think it's like an F1 or an F0. And but anyway, that's the first April in recorded history, or well, recorded history. I don't know how far back it was in Oklahoma, but no April tornadoes this year in Oklahoma. Very, very interesting. A testament to the persistent cold over the central U.S. that we have suffered from as well as them.
Right.
But I remember Ryan was talking about, oh, watch out, this could change next week, because that was almost the exact response. And I remember thinking, yeah, there's a chance. Never really materialized. There's some severe weather that came across this part of the country this week on the 2nd, 3rd, and even some perhaps today, but not really a big outbreak.
Right, it's a little bit closer to us, right, in Iowa.
Yeah, there was a tornado in central Iowa, right outside of Des Moines. And that was on the 2nd, or was that on the 3rd yesterday? Maybe it was yesterday. I saw the SPC page. I think it was yesterday, not the 2nd.
Yeah, and Janesville got drilled with hail and high winds.
Is that right?
A lot of damage it was on Wednesday evening down in Janesville. A lot of damage down here.
Yeah, so pretty interesting week, but not as explosive as maybe we thought would possibly be the case.
If you recall the discussion last Friday, we were talking about, first of all, just a little interesting tidbit. For April, while Oklahoma hadn't had any tornadoes, I think beating Oklahoma were actually, I think it was Idaho and California with 5 and 1 respectively.
Is that right?
In terms of tornadoes. So they'd actually had some severe weather. But the other aspect of the forecast was this potential for significant rain in the central part of the United States. And it looked like, at least initially, that the heaviest rain band, that axis, would be just south of us.
Yeah.
But we actually, I guess this boundary moved a bit further to the north of that broad subtropical ridge that was expected to form. So,
we had 2 days, at least 48 hours straight with 2 points over 60.
Right.
And in much of that time it was precipitating. So the water was standing still almost pretty much in that one spot. Now they've gone down. We'll see that.
And the discussion also was for us to be, will we get 70?
Yeah.
And
That's
then
right.
2 days later, we were over 80. So
That's
that
right.
was just an amazing.
I think the same thing could happen tomorrow. We could be really warm in the afternoon tomorrow. And one last note related to what you said about the tornadoes in Idaho and California. When's the last time you said Idaho wins? It doesn't happen that often, so it's something to take note of. Okay, let's go to the surface map.
Sorry,
Yeah.
just one last April tidbit. I guess the warmest April temperature ever recorded was observed in Iran or Pakistan at like 50 C.
Oh, yeah, that's right.
Yeah.
That's right. Was that 113 Fahrenheit or something?
122.
Oh, 122. Yeah, that's right. I did read about that. I didn't know the number. I heard that it was exceptionally warm. Yeah, that's amazing. Warmest April ever. That's amazing. Okay, so it was from sort of northwest Ohio down to like in there. So yeah, that is about where the cold front is, isn't it? Yeah.
It's maybe just a little bit further
60-degree wind
west.
shift. And then the real cool and dry air comes in a little bit further back here, doesn't it? So,
Yeah, but the interesting thing is the pressure trough, you can see, here's what, 1,010.4, 1,013.2, so the pressure trough was right in here.
yeah, so that's
It leads the wind shift a little bit.
okay. Yeah, so that's what's going on with that. Those lines of thunderstorms, which are spacing themselves in between stations, but we can see them on the radar, are right about along the cold front, at least the leading pressure trough associated with that structure. Yeah, that's interesting. Okay. So we're 64 over 53. Much of this, the last half of the week, we were, 70 something over 61 or 2. So cooler and drier. And drier still to the north. Look at these dew points are in the low 30s on the northern border of the state and in the mid to low 40s further to the south from there. So we have a tendency to get really dry afterwards.
Can you beat this? I mean, then you have
No.
74 over 35. That's probably, I'll say, close to perfection. Maybe a little too dry.
Almost a little too dry. A little too dry compared to Greco-Roman times where much of Western civilization was built. It was probably mid-70s a lot of the time, dew points hovering near 50.
Right.
Yeah, and that's where, Socrates and all those people were thinking about stuff. They didn't have to worry about dew points in the 70s and 80s and all of that nonsense in tropical storm. But anyway, yeah, that's right. That's hard to beat. 74 over 35. It's a pretty nice day. So, and we're going to have something comparable to that, I think, tomorrow. So we're going to have a really nice day tomorrow. Okay, I think that's about the only place it was raining. A little bit of light rain over New England, but that's tied perhaps to the storm. And then we wanted to see what's going on. Both of them. Let's see if we can, no, New England don't care so much, but let's see if there's anything on any of the reporting stations here. Doesn't look like it. But then here where we had our convective elements is heavy rain in Dallas and a thunderstorm just to the southwest, light and moderate rain in the area. So there's a few stations that are reporting the occurrence of that fairly intense convective feature in east central Texas. So that's heavy rain, 4-star rain, 4-dot rain, whatever, 65 over 63. Pretty good. And then I think the Pacific Northwest was no precipitation there, except maybe far up in Washington, Oregon. Let's see what we get there. North. Yeah, so I guess none of the reporting stations are mentioning any rain in the Oregon, Washington, west coast of either state. Okay. 55 over 44 in Seattle. That's okay. Let's go to the superpeats. Try and get an idea of where some of the structures at upper levels are in relation to these features that we're seeing in the surface. So let's go to 500 millibars. Not the loop. Oh, sorry. So here's our 500 millibar map from this morning. And our cyclone center is about over northern lower Michigan. And then the warm front extends to the east. I think some of the light precipitation in New England is tied somehow to that. Then we have, even at 500 millibars, the leading edge of the cold advection is right about where it should be relative to what we just saw for the pressure trough at sea level. So that's kind of a nice signal. Here's the upper level trough axis, and it's just down sheer of that, of course, that we have our cyclone developing, continuing to develop, I should say, over Michigan. And then this trough is not quite connected, I think, to the one that's down over Arizona, New Mexico, but there's a trough axis through the northern part of Mexico itself and into New Mexico. Down sheer of that, in a very rough sense, is where some of this convective activity is going on. I don't see this as a major forcing mechanism for what's happening hundreds of miles to the east. It's also possible that there's a little bit more waviness in flow right here that's hinted at by some of the winds and even the geopotential height analysis. So maybe there's some little embedded shortwave. At very low latitude, it doesn't take very much to get a nice response because the stability is lower. So that's a pretty good event going on there. We haven't looked at the West Coast satellite image, but that's, yeah, I want to do that next anyway. I wanted to show this first. Look at this air just south of the Aleutian, minus 36 at 500 millimeters. That's pretty cold for that latitude at this time of year. And there's a really intense baroclinic zone. Minus 20 defines the sort of peak of the warm sector at 500 millimeters. A very strong horizontal temperature contrast and strong cold advection associated with a fairly deep upper disturbance, 5,072 meters in its center, right on the to the west of Kodiak Island. So that's a pretty intense upper disturbance. There's a much weaker one, several hundred kilometers to the west of the California-Oregon coast, with not so cold air in the middle of it, minus 20. And we'll see that that also has sprouted a nice little disturbance to its east in that location. And then I think one last thing I want to point out is, for purposes of the forecast, a couple of days or maybe 3 or 4 days into the forecast, this region here in northwesterly flow with relatively cold air, minus 37 on the archipelago, a little bit of a trough there. There's a little bit of cold advection at the leading edge. I have a feeling this is a place where we're going to have a development of an upper wave come across the southern part of Hudson Bay. There's a fairly intense cyclogenesis event on Tuesday or Wednesday of next week, well to our north, that will kind of re-usher some colder air southward. I don't think we're ever going to see the depth of the cold air, but it's going to be a fairly intense mid-spring storm going across southern Hudson Bay. And I think this might be the seeds of the development of that event. I can't remember if I get the timing right in my head. I looked at a longer-term forecast. I think that's about right. That's over one of the Great Slave Lakes, or I forget which one's which. Great Slave Lake, I think, is the big one. Okay, let's go to 700 millivolts.
So I'll just point out that circulation that was over the Bahamas, you can see it's cold in the core, it's certainly cold in the center of this. But also the temperature gradient, broadly speaking, isn't particularly significant, at least at this level. And we just want to watch that as we go further down.
Yeah, that's a good point. So we'll see what it looks like at 700. It's clear, here's the clear inverted wave, inverted trough structure. And it seems as if it's got a little bit of extra cool air on its northern edge. Yeah, that's not really a very coherent looking picture, but where there's cyclonic vorticity, there's cold air. So I guess that's consistent. It has a cold core type disturbance. Here is the 700 millibar reflection of our structure across from the Great Lakes all the way down to Texas. It looks a little bit more organized or connected along that whole length in the lower part of the troposphere as opposed to the middle troposphere. But again, the cold frontal boundary that we seem to get from the surface analysis is just exactly parallel to the leading edge of the cold advection, as you can determine it from the isotherms that are put on this map. So it's a really deep, probably coherent frontal structure that's coming across, has already gone by us at the surface, but it's coming across the eastern part of the Great Lakes states during the day today. Again, right around Great Slave Lake, a little bit of a depression in the isotherms indicates, and a little hump in the geopotential height indicates there's a little bit of a out of phase relationship between the wave and the geopotential height wave and the thermal wave, which is nice for development. And here's what our upper level cyclone at 500 looks like at 700. It's 2,600 meters. That's really low, not surprising. And a very intense baroclinic zone, connected nicely, I think, to what's going on at 500 millibars. So that's a really deep cold frontal structure, at least down to 700 millibars. I wouldn't be surprised if we see it also at 850. So broad, but modest baroclinicity across northern Canada, central Canada, with a northwesterly flow across it. There's a tendency to be making the horizontal temperature contrast a little stronger just to our north. And that, I think, lurks somewhat menacingly to at least keep us on guard for when does our warm spell end. We'll see. Okay, let's take a look at 850 and then we'll go to the jet level. First thing I want to point out is, I guess, here's the inverted wave trough structure over, sort of centered over the eastern half of Cuba in the Lesser Antilles. And there's not an obvious cold core structure anymore at 850. So it's cold aloft. It's maybe trying to figure out what to do in the lower troposphere. It's cooler, I think, in the middle of this thing than it is surrounding to its east or west. But it's not deeply cold. Here's the 850 millibar structure at upper, for our cyclone, and it's just about coincident with the surface cyclone, which is over eastern lower Michigan. And again, the cold frontal baroclinicity really does line up nicely with what's going on at 850. So that's a nice structure, actually. And then here's maybe the first semblance of some sort of structure in the lower troposphere that's down shear of the feature that's getting itself organized a little further up to the north and west. So there's some sort of a cyclonic disturbance with an out of phase thermal relationship there that's kind of ripe for development over northern Ontario. And then finally, our cyclone off of the, along the Aleutians. Again, the 850 millibar temperature structure is quite intense, about the same order of magnitude in terms of its intensity. Every level displaced a little bit further to the south because the whole thing tilts back to the north and west with increasing height. But that's a robust cold frontal structure associated with that storm that's affecting the Aleutians right now. And for us, one gets the impression that there'll be modest, if any, cold advection during the day today. There'll be plenty of insulation, plenty of forcing for subsidence, weak though it might be, but persistent over and to our west. And so we're gonna have a nice afternoon today and tomorrow, and not really worried very much about the cold air until maybe later in the weekend, Saturday night and Sunday.
Hey, John, I'm just curious, for this, the front that's out over the south of the Aleutians and the North Pacific, would you say this is even more remarkable given the fact that it's over the water? And that if it was over land, you might, over water, you might expect there might be significant mixing that would sort of obliterate any frontal sources. Maybe this isn't far enough.
Let's see what the analysis says at 925 along those lines. Because this is still about 1.25 kilometers above sea level. And it does get weaker. Although maybe also just displaced. I mean, there's a strong baroclinic zone back here at 925. It's just not quite as strong right in this location. There's definitely got to be some moderation that goes on there, depending on the actual temperatures we're talking about. This is +5, I think, at 850. Yeah. So, and the water temperature is +10, so approximately. So even lower than this, it'll get eroded away. I think you're right. I think you see the structure kind of emerge at about 925 millibars. But it's deep. It is a deep structure, and it's really nicely put together, I think. So that's the word on that. And at 925, one gets the sense that there's even better organization to the thermal advections associated with this developing wave in northwestern Ontario. Strong cold advection over Manitoba, pretty decent but local warm advection over Hudson Bay itself, or James Bay. So, and that's all pivoting around this cyclone that's getting itself organized in the lower troposphere. So pretty interesting, just to our north. But let's take a look now at the jet level. We could.
300 or 250?
300 first. Yeah, thanks. So at 300 millibars, kind of a complicated map. So we've got a couple of things to look at. Here's the polar trough that's associated with, actually the axis is down here, associated with our storm. And then a jet well to the north and east, in fact, well north of any of the precipitation or cloud mass that we saw even on the satellite. So that's interesting, and we know it's convective because we got really heavy rain rates over us the other day. I don't know how much of this might be outflow from that precipitation. It's kind of interesting that it's got that orientation, it has that sort of look. I wonder what the most northern latitude where one ever sees a really strong outflow jet is. We must be bordering on it about here, I would think. Let's say divorced from extratropical transition.
Right.
That's pretty interesting, isn't it? It's right there. Then we've got this jet associated with our strong cold frontal structure tied to the storm off the Aleutians. And then we haven't looked at the West Coast satellite image. We'll do that for the last thing. But off the coast of California and Oregon, remember at 500 was a better looking upper trough than it is at 300. But there's a weak jet associated with it at 300 millibars. So all the things are working in about this area for general forcing for subsidence in the core of the upper disturbance. So it's kind of developing. And then we had our heavy convection over eastern Texas. Again, I'm not sure how much of this wind speed maxima has been fed by outflow from that disturbance, probably to some extent. But this is also aligned more or less with the position of the deep cold front that we saw all the way from 500 millibars downward. So this should be a region of strong vertical shear. It seems to be a region of pretty strong horizontal temperature contrast. And we're in an interesting spot in this jet, left exit region, just downstream of the upper trough. That's at 7 a.m. This is the lingering bit of clouds and precipitation that we had this morning. And now that's all presumably moved further to the northeast. Put us in a spot where no longer do we feel the effect of the upper trough nor the jet dynamics. Let's go to the West Coast satellite image next.
You have to go back one. I'll go 16. You go goes west, you're right down.
It goes west, right? West.
So here is the cloud signature associated with our beast up over the Aleutian. We can slide down a little bit. That's a pretty intense circulation. Hard to know how the oblique angle kind of biases the way that it presents itself, but nonetheless, there's a really intense circulation just over the far eastern part of the Bering Sea, and some open cellular convections evident. We saw the temperatures are about minus 36 at 500 millibars, so these are probably around minus 30-ish or something like that. And then a little wave coming up along the cirrus cloud edge, which maybe is tied to the invasion of this upper disturbance. So we didn't get that far west to see that, if there is one at the upper levels. But you can certainly see some interesting stuff in the lee of the islands. If you look very carefully, there's spaces between these convective blowups that are more or less the spaces between the islands, at least initially. That's interesting. I wonder what's going on there. So very intense cyclone, cold polar air fueling it. And then here's the one off the California-Oregon coast. Beautiful, nice baroclinic leaf structure well to the northeast of Hawaii. It looks even better developed than it did earlier this morning when I stole a similar movie for my class. We had a really nice baroclinic rotation to this development. And there's maybe the upper level trough itself, the coldest air aloft. So it's a kind of a nice event, and I'm not sure what the time scale is for when this bears down on the Pacific Northwest, but probably not very far from now, sometime during the next 24 hours. And then this maybe is connected to some stream of clouds and presumably water vapor out of the subtropics that are coming across at about 170 degrees west. So that's interesting. I think that's all I have for the current conditions.
Okay, I'm going to just bring up a couple things. And
X marks the spot.
so this is the last one. Oh, do you want to look at SPC while we're?
Oh, yeah. Let's do that. So that's today, right? So yeah, marginal risk down over the southern portion of Texas and then towards the coast. Enhanced risk up over New York State and Vermont. And then it's all tied to the cold front, at least the northern portion of it. And this here is maybe connected to that convective event that's going on in the central part of the state. So not really any particular concern at SPC for what's going on there in the eastern part of Texas.
One last. Oh, not CPC. I'll get up there in a second. I'm just trying to get. Photo watch. Here we go. Under that. Okay, thanks, John. And
Pete, you want to drive?
sure. Meteorogram. So
There's no such thing.
There is no such thing.
Mediogram, everybody knows that.
Meteorogram. Look it up. AMS Gloucester Meteorology. Sock.org/gloss.html.
Wow.
I made that up. But anyway, forecasted temperature, dew point, and rainfall. If the models were suggesting a little bit of light rain early this morning, that departing trough. The cyclone is now over Michigan, moving to the north and northeast. And then basically a fairly quiet weekend, and then maybe tomorrow evening, a chance of a shower, and then that lasts through past 1 a.m. on into Sunday morning. Sunday probably a nice day. We'll look at the time height section in just a moment. But big features are, it's a fairly warm weekend. It looks like Sunday, this might be the passage of that weather system that develops in Canada, the front that goes by.
Yeah.
We begin to cool off. We're back into the low 60s or so, low to mid 60s by the time we get into Monday. Sunday might be a slightly cooler day than Saturday. Let's look at the time height section first. So the time height section shows our departing region of ascent as the upper trough moved by. We're in this period of subsidence. Develop a nice well mixed layer during the afternoon with the sun coming out. Right, sun, and it looks like maybe some cumulus are going to form, these fair weather cumulus with a cold advection over us, but probably high based cumulus that are going to form. And overnight, cool off, boundary layer gets a little bit shallow overnight, and then well mixes out tomorrow But also, looks like we have some cloudiness and just a threat of some precipitation, fortunately, in the late afternoon or late evening. We'll check to see what's the factor that brings that in. And then following the passage of this next period, big impulse of vertical motion and the lowering of the tropopause, we see the winds shifting north and then northeast. As a large anticyclone, we'll see builds across southern Canada and the upper Midwest, bringing us northeasterly winds and some cooler temperatures. So I imagine early next week, folks that live right along Lake Michigan are probably going to have a pretty chilly week, whereas inland over here will probably still manage. They may be in the 40s or so, but when you get to the central part of the state, probably in the 50s or low 60s. All right, so let's actually see how this all pans out on the maps. Before I do that, I want to just go back up. I jumped into this without, if you go back to the tabs at the top. I did want to just point out, the somewhat unusual, if you go down just a little bit more, you'll see this special tropical weather outlook for the Atlantic and tropical and Caribbean. This is from 10:45 this morning. This is just Hurricane Center's looking at this area. We don't often do this. They will wait until June 1st for the Atlantic to begin issuing regular outlooks. But because of this area of upper level cyclone that's seen there with the surface trough, moving westward with no significant development expected with this, but expecting some rain and gusty winds. And we'll see in the GFS forecast as well as in the MM5 forecast, there are fairly tight pressure gradients, so the possibility of some strong winds as this goes by. But the chance of it be developing into a tropical cyclone itself explicitly at this point near 0%. Not zero, near zero. So there's always, I don't say hope, you don't want to see damage and destruction and injury, but it would be interesting to see an early season event.
Yeah, don't worry. If this one doesn't develop, there'll be 5 other ones this year.
Right, and they'll all have names.
Yeah.
Unlike the cyclone that passed by last night. Okay, so we go back to the MM5 forecast. First of all, let's look at, I'm going to focus on the tropics first, then we'll look at the latitudes. And you can see this disturbance that shows up in the TV contours as sort of this weakening disturbance over time. Again, this is cut off PV. See it moving westward.
I think it gets energized, doesn't it, when it goes back up in the southwesterly flow? Watch that. It kind of,
Oh, yeah.
does it? Or is that a different feature?
Something shoots off to the northeast, but it's not.
I don't know if that's the same one.
And then over us, again, this is in a layer in the lower troposphere, and I should have isobar learners who can actually check it out, but if we could go back and not move it, I'm sorry, Pete, we'll stop it and just go through, sort of 6 hours, we'll go every 12 quickly. So here's our departing upper trough this morning, or by this early this afternoon. You can see sort of this banana sheet region to the north into Ontario and Quebec. This is likely diabatically generated, that's sort of a characteristic feature north of the warm front, perhaps. And then south of the cyclone, again, this is perhaps partly diabatically generated PV in the lower troposphere. Here's our upper trough, which shows up very nicely. I believe this is perhaps the next feature that John was looking at in the forecast that's going to energize that surface cyclone to our north. So let's go ahead 12 hours, please. That feature is moved on northeast by 1 a.m. tomorrow morning. Here's the next little slug of vorticity moving into western and northern sections of Ontario. But there's sort of a, I would call a broad upper trough, just a PV maxima back in the northwest flow. This may not be the feature that Tom was looking at. Let's go back a quick, another 12 hours into tomorrow in the afternoon. As this big, broad vortex rotates around, you can see a few little undulations, southward protrusions from the main body that does vorticities or local PV anomalies, but none of them seems to really strike me as being particularly interesting yet at this point. But if they were to begin to amplify with PV convection on the southern side, you begin to see sort of higher guys of PV sort of protruding southward from this feature. Okay, let's go back. Of course, this black area here is just sort of the outcropping of the isotropic surfaces as the ground heats up overnight. So finally, again, beyond our domain, we begin to see a nice well-developed trough that's going to pass through the just north of the Great Lakes. There is Clipping Lake Superior, and you can just imagine if we're looking at the Survivor Boulevard, which we'll look at in a moment, this trough right here, you might expect a big, broad anticyclone to begin developing just north of that region. that we saw in the time height sections ushering in the cooler air, and that's perhaps what we're going to see. Let's go back a quick peek and go to 54 hours. So it's really interesting is the evolution of this very broad upper trough that we saw over eastern Canada and central Canada. And due to things that are outside of this model domain, or at least the maps that we're showing right here, this gets narrowed very quickly to a very sharp feature, which has the potential, if there were baritonicity at the surface, to generate a surface cyclone. And again, we might expect at upper levels to see a broad ridge developing over Manitoba and Ontario.
I wonder if, bring up a good point about the baritonicity. What if you have sunny skies out ahead of the northeast corner of Lake Huron? Ground heats up and you got a relatively cold lake. That's a baroclinic zone. It's not the traditional one where you think about the warm lake doing it. It's
Right.
the opposite, but that's still a baroclinic.
Yeah, that's not great baroclinicity. And so you're saying the surrounding land then would be.
Yeah,
warmer.
yeah,
So
right.
you get a reverse gradient of surface.
Right.
So let's take a look at let's look at the surface. Let's look at the 850 millibars during the same time period. Start off here. Again, we'll note this inverted trough feature here, and you'll see over time it begins to warm up a little bit there. Here is that nice, sharp mid-trope or lower tropospheric baroclinicity associated with cold front as forecast by this model. I've already described that. And you can see, obviously, the geopotential light contours in white. It shows it really nice in the trough axis and the thermal gradient. Shows it really well. Right. 12 hours. You can see that cold advection continues over the upper Midwest into the northeastern part of the United States as the cyclone continues to wind up. Notice again warming occurring in the center of this inverted trough. So it's becoming a bit warm core at the surface, and that may be in part due to convection and surface fluxes of moisture and heat. And we're meanwhile in this northwesterly flow with sort of modest, weak cold advection over us. Let's go back.
I see that 850 millibar thermal and geopotential height field. Yeah, right across southern Manitoba and southern Alberta. It's got a couple of little waves in it.
Right. And maybe those correspond to the waves that we saw on the PD surface. Those little
Maybe,
small
yeah.
undulations. And so, yeah, if they just get into the right phase, you can begin to see amplification. But you also note here on the very edge of this, and again, since the edge of the model may be somewhat suspect, but these winds right here, they suggest low PD advection into the edge of this one, which may begin helping amplify a ridge.
Yeah, really.
Let's actually step ahead just 6 hours from this, 24 hours. You can sort of see that wave right there. Here's a trough right here that's developed, and really not much further down the east. This has a nice pattern of warm advection, cold advection beneath it for the trough axis. That's has the potential to amplify, and maybe even this one. Notice our temperatures haven't changed much at 850 at this time period. And this has gotten even warmer.
Yeah, one gets the impression that's pretty robust penetration in a low resolution model. Those are going to be interesting to watch that in the next couple of days.
Yeah, so really, and you can see again that with the gradient to the north are really strong. So let's go next to just add 12 to it, please. And by tomorrow, if the time's right, so by tomorrow evening, really strong warm advection occurring as this wave begins to amplify. You see cold advection here, nice trough, warm advection downstream of it. So this is beginning to develop baroclinically, and that can perhaps also help sharpen up the trough as this interacts with perhaps an upper wave. So this is the potential for this development. The fact that we have this local warm advection here also might foster some, if we were looking at Q vectors, and we can look at that in a second, maybe some modest divergence Q vectors here leading into this warm nose, which would support assay. So if it's moist enough, we might get some precipitation. Again, I'll just, in passing note, by this time tomorrow, the wave axis is over the Florida Peninsula. But it's warmed even further, at least by the aerial extent of this brown area that's 16 to 18 degrees C. Okay. 48. And so this is by Sunday morning. You can see our front has definitely passed us. We're now in cold advection. The front is, surely the surface front's probably through northern Indiana, northern Illinois by this time period. The cold advection coming in here is this broad, sprawling anticyclonic circulation with cold advection in the base of this thermal trough, which in the geopotential fields, we might expect to see height rises at the surface in this region. So this big broad anticyclone can also begin amplifying at low levels. The upper trough itself also amplifying as well. Nice warm advection across the top of this as well, which is going to increase. It's going to begin lowering night trends further to the north. Okay. Go back a quick. And what hour was that? That was 48 minutes. I'll find that out at 8:50. No, after this, I'm sorry, 12 hours, so 60 hours. It's a little bit further out than we were.
Ooh, yeah, it's cold.
So this forecast and with an amplifying wave looks pretty chilly with cold advection over there. Coldest cold advection right over us by the time we get to Sunday evening. So Sunday looks like a potentially dismal, or that's not a word, more dismal day than Saturday. So during this time period, we saw that there's one period where we might begin getting some precipitation. Let's go to look at the 0Z. The Q vector is 7 millibar. Q vectors, that would be at 36 hours, I believe. And there is some modest, again, this is a very messy map. Depends on how you do the derivatives and how you average this up. But this was ahead of the, in that where we saw the warm 850 millibars, that sort of warm thermal grids that was being developed. Here is some modest Q vector convergence that extends from this northeast of Green Bay across our state, southwestern part of our state. And that's just ahead of the period where we're expecting to see perhaps some precipitation. Go back, and let's actually look at the 700 millibar map at the same time. Actually, interesting enough, the vertical motion is actually a little bit further to the west of this. I don't know if you have any sense.
I wonder
can sometimes be messy.
Yeah, I wonder if it's just forced at a different level, and this is, the main forcing's higher than 700 millibars. Might be that, I don't know.
We'll just take a look at 500 millibars at the same time.
That doesn't seem obvious to me.
That's 300.
Oh,
Okay.
no, sorry,
Nothing
no
obvious
rescue.
here.
Yeah, it's not obvious. There is
There's probably a lower tropospheric feature.
Yeah.
And we can zoom in on that if we click back for a second, Pete,
maybe
and
it's
scroll down to this. Let's look at 850, 36 hours. Not really.
Yeah, I'm not seeing it. Arguably, your strongest warm advection is right in that location.
Right, a little bit of a wave in the winds up here.
In here, so this is right up here. Actually, is probably where the strongest is with the warm front, right?
Yeah, that's
So the
right.
warm front's well to the north.
That's tricky.
It's the forecast, and then you can see that again the gradual wind shift to the northwest with the cold advection beginning. Let's go just 3 hours ahead on this speed. 39. Hold off, but not really. This is not exciting me in terms of like there's a
Me
clear
either.
signal.
Yeah, no, me
for
either. No.
housing.
Glad it's not a mandate that we understand it, because it's hard to understand.
Right. Let's go back a quick, and let's also look at the surface at 36 hours. Can we see anything there? This is an inner grid from the model.
There is pretty good differential cold advection in that region where the air is ascending.
Right here. This is precip.
Yeah,
Right.
but proxy for the
Right.
ascent. It's pretty decent, but it's not localized. So I don't really know how to make sense of it.
Right. You can see the impact of the lakes relative to
Yeah.
the surrounding area. And those are just light precipitation, so maybe this is that's not too big a deal. But the model of the forecast is maybe a convective system actually. You can't use any QG diagnostics to figure out the vertical motion. It may very well be convective.
Yeah.
With the low center just passing by. We go back to 33 hours for a second, just to.
Yeah, that's mystery.
Mystery, but we can also, you don't have to rely on one forecast model. We'll look at the TFS in just a second. Go back, and finally, let's look at the surface map. 36 hours, I'm just gonna focus on that one time. At surface, we'll increase it. Yeah, a very weak disturbance that moves across the northern part of our state. Light precip. In fact, it's so light that maybe within the model noise. So let's go back and click, and we'll look at 60 hours, and then we'll just look at quickly at the GFS, the little site to see it. So here's the sprawling anticyclone that arrives over us as we start the next week. This is on Sunday evening. To the cold advection over us, cold thickness advection. So it should be a nice day, but perhaps a chilly day. And again, right along the immediate lake, or that's probably going to be really chilly early next week. The remnants of whatever that disturbance was, I'm stuck caught off the east coast of the United States.
See, on the northern part of the domain in over Hudson Bay, that's the big storm I was talking about. Yeah, so it's that feature.
So let's go to pivotal. We'll just go 36 hours to see if it has any. So it's 36 hours and we'll go to preset.
Oh, it's got elements of the same, but not the same thing.
Right. This does not look good at all. It looks like most of the preset is maybe the low is a bit further, slower.
Yeah.
Leave them off forecast or whatever. Northern part of our state. We'll click ahead to 39 hours. I'm not going to spend too much time.
See, that stuff's
slower
still look.
regression.
Yeah, and it looks like it's more frontogenetic. And
Right.
then the precipitation forecast lines up along that region of strong frontogenesis.
Right.
I'm presuming is it. Yeah.
Okay, and get to 60 hours. I'd be interested to see how different this forecast turns out to be. Ultimately, kind of the same, right? From the big anticyclone over this region, and then with cold advection also displaced a little bit further south. But here's this next region of really strong warm advection all over north. We'll just step through that. Let's go 96 hours. Really quickly. That may be too much rain. Sorry.
That's a pretty intense storm in Canada.
Yeah, well to the north, again, outside the domain that's being plotted right here. Unfortunately, we don't have to deal with that, but this broad anticyclone can slowly just take some residents over the northeastern part of the United States and us, and we're still going to get a nice day, but it'll be cooler relative to what we've experienced and perhaps drier. Put 120 hours just to step out a little bit. We're not going to get to next September, unfortunately, in the forecast. Yet another one moving across the
Yeah, it's active period across Canada.
So in short, it looks like nice day tomorrow. Maybe a few clouds and maybe a sprinkle in the late afternoon, early evening, and then we turn cooler for late or Sunday into Monday.
We should see what Saturday next week's going to look like, graduation day.
So 180 hour, that's probably not enough. Only Sunday night or Saturday. Yeah. Go to 192 in the morning.
That's pretty good if it verifies.
Pretty good if this verifies, but you know, the rain to the south, go ahead to another 6 hours to 18Z. Not too bad. And one more, just can we peek out, still dry over us.
Oh my God.
Yes, Bailey.
So this is post-graduation, so let's go back and look at the 6 hour, the 60 forecast. And hold it off. Let's go back and look at the one from last night. That's much better. I like this one.
Let's go with that.
Let's just take that. Click on that save.
Yeah.
And a couple other things just to look at. Again, this is kind of a quiet period. The CPC, that's not there. Oh, I have it up here. Climate prediction site. Just looking, they have their seasonal outlooks. So it might be, since we only go a month ahead in the CFS, maybe we can just look at the upcoming forecast for the upcoming summer, June, July, August, in terms of temperature. So the shading here just reveals the likelihood of probable exceedance in temperature, and it looks like the western part of the United States, these contours here, 80%, 90%. Anything not shaded is less than 10% above or below normal, and so this doesn't mean really warm here. It just means likelier that it'll be above normal out here. This is kind of in a region that's somewhat indeterminate in terms of the signal that the Climate Prediction Center has for the our June, July, August period. So
it does suggest northwesterly flow over us, doesn't it? I mean, that would be the underlying reason for this.
A big broad ridge.
Yeah.
Maybe a trough, and then maybe so ridging off the east coast of the United States.
Yeah.
Look at it this way.
What do they do for precipitation over New England?
Yeah. So let's take a look at that.
Hey,
That's
that's it. That's your answer. How do you
So
like
the big
that?
broad ridge here, this might be part of the monsoon period.
Yeah, you're right. I think that's right.
And then, so it'd be nice to see what the mean forecast they see, or what the signal and the CFS is for the broad pattern, the average pattern over the course of June, July, August. But we can always talk about this back in early September when we do Weather Watch. what the summer looked like. But, I wouldn't mind a northwesterly flow most of the summer.
I know, I
It's
mean,
dry, that's,
Those are great summers
It could
here.
be
We've
warm.
had some recently like that. They're great summers here. No bugs,
Yeah.
no water, and it's great.
Bugs after these few days.
I know, no, that's definitely right. It's a real head start for some of the early species of mosquitoes. Don't like those guys.
so really, that's CFS. Gonna go really far out, so this is,
768 hours. Okay.
June 5th.
It's like
He
a,
clicked on it, not me, although I would have.
it's like a D-Day forecast.
Look at that, I mean, that's also, that would be a
Yeah,
wonderful day. Temperatures, I'm gonna get 62 meter.
wow. That is pretty good.
Model's off, but
You're good. So just take a 5 off the thickness,
Right,
and you're right about there.
it works all the time, right?
Yeah, pretty good. It's good in Seattle, too.
The 5 off, which end?
Yeah, the thousands.
Right, okay, so if we were to believe this, this would be certainly a pleasant 7 p.m., low 60s, and a dew point, all right, we have dew point on your eye, we don't. Oh, no, I'm not looking, 45.
Pretty good, 55.
Okay, well, that's too much.
I bet it's really hard to get to 45 dew point in June.
Unless you're in West Virginia.
Yeah, that's a dry state.
Anyway, thank you all for coming over the course of this year, the last 2 semesters, and thanks Pete for driving often and getting really nice graphics in terms of updating our satellite images, and John sort of leading through really wonderful, insightful discussions.
Yeah, thank you.
Just the questions from the audience have been great. So see you all next, or many of you, in September.
In September, yeah.
Unless snow or likelihood of a big hurricane that John gets so excited about.
I do. No, I do like them. When I like to talk about them, I just don't know anything about them, and that's just my ignorance.
Congratulations, everyone, for earning degrees in the next.
Yeah, absolutely.
Or over the summer. So, all right.
All right, thanks. Another successful year. Very good.